Walking on ice feels like a comedy show. Walking on pavement? Easy. Why? Let's find out. Friction is the invisible force between shoes and ground. It keeps you from sliding all over the place. When you walk, your foot pushes back against the floor. Friction pushes right back, letting you move forward instead of doing the splits. If there's not enough friction, like on a slick floor or an icy sidewalk, walking becomes a real challenge. That's why tires have.
Hello students. So in this video we will discuss a very important concept regarding friction, regarding net forces, resultant forces or reaction forces. There was a question that was asked in the standard 11 exam that how friction helps in walking, and this concept is very useful for 11 students, 9 students, 8 and 10 students, because they must understand the concept of resultant force. Now you have to understand very carefully what is going on. See, you have two diagrams here, and these diagrams show how friction helps in walking. So when you are walking, you are actually applying a force in the downward direction, which is F. This one is the force, F. As a result, the ground applies an opposite reaction force, which is F dash. And from Newton's third law, these two forces are equal in magnitude and opposite in direction, and they are of course acting on different objects. F is acting on the ground, F dash is acting on the feet or on the person. Now what you have to understand, especially addressing the standard 11 students who are doing numericals with resultant forces and net forces, there are many numericals. What you have to understand is that both F and F dash are forces that are resultants, that are the resultant of two forces. How they are resultant of two forces? F is the resultant of FH and W. FH is this force which is applied on the ground. FH is this force in the along the horizontal direction, and weight is acting on the downward direction. So their resultant is acting in the fourth quadrant, which is F, and F dash is the resultant of this friction force and the normal force that is acting on the person due to the ground. So F is the resultant of FH and W, and F dash is the resultant of FR, friction force. Here comes the friction force. That is the key point in making walking possible on the ground. Friction force and W, weight. So both of these forces are actually resultant forces. You can see in the diagram. And these forces, they cause this F dash and F. Now suppose there is no friction, what will happen? The question is, if there is no friction, then what will happen? Then what will happen? What will happen? Now if you observe this diagram carefully and try to imagine the situation that if this force is not present, if this force is not there, what will happen? Try to imagine this thing. In this case, what will happen, that if we eliminate this force, friction, if there is no friction force, then this F dash will be 0. F dash will be 0. In that case, if this force that you are applying on the ground, it cannot be balanced, and what will happen, that due to this resultant force F, you will slip, you will fall on the ground. That is why friction is essential for walking. So if there is no friction, then the force F dash, there will be no resultant in the second quadrant. Force F dash will be zero, as there will be no resultant of N and Fr, friction force, which is of course zero, it is not present. There will be no resultant. What will happen then? F cannot be balanced, and because F dash is balancing the force F cannot be balanced, and the person will slip, due to F. You must have slept, or you must have fallen on a slippery ground sometimes in your life, or you have seen people slipping on a slippery ground, or where there is water, or where there is oil. What I mean to say is that where there is no friction, and this is the reason they are slipping, because this force F cannot be balanced by F dash, because there is no friction. So when you have friction on the ground, simply you can answer that when there is friction on the ground, the force applied by the feet on the ground is balanced, which provides a resultant force, and due to this resultant force you can walk. So this is the very interesting example of resultant force in practical life. When there is friction, then the force applied on ground is balanced by F dash, which is due to friction, and thus walking is possible. If friction is not present, F dash will be zero, and you will slip, you will fall on the ground. This is how friction is helping in walking on a surface. We say that friction is a necessary evil. It is necessary because it helps in walking. It helps in starting many types of motion, which we will study in the case of rolling motion and rotational motion. It is evil because it causes dissipation of energy. It causes wear and tear of mechanical parts. That is a separate story. But you cannot neglect friction. Whenever you are walking on the ground, basically you are applying a force on the ground, and that force is balanced by a resultant of friction force and normal force. If friction is absent, that reaction cannot be balanced, that reaction will be zero, and you will fall on the ground due to the force that you are applying on the ground. That force will make you slip on the ground. So this is the basic physics that you must understand. It is not that if there is no friction we will slip. It is not a proper answer when you are studying mechanics, when you are studying resultant forces, vectors, and other important concepts in physics. So I hope you have understood that why friction is necessary in walking. why friction makes walking possible. You have understood this concept. This is a very simple but very interesting concept, and it is a direct application of resultant forces. This resultant force is sometimes called as the net reaction force. The resultant force is also called the reaction force, or sometimes we call it normal reaction. We will discuss many examples of normal reaction force, and we will realize that normal reaction force, which is again misunderstood by most of the students, that normal reaction force means it is the force due to weight, mg equal to n. No, normal reaction force is a very in-depth concept. We will see how this concept helps in solving many problems. There are many practical life examples. There are many situations where normal force is not merely the weight or a force that is equal and opposite to weight. Any force can provide normal reaction force. So again, I conclude with the answer that when you are asked that why friction is necessary for walking and how friction helps in walking, you must answer that friction provides the necessary reaction force in response to the force applied on the ground. When we are walking, we are applying a force on the ground, and that force is balanced by the resultant of normal and reaction force. If friction is, normal and friction force. If friction is not present, this force F cannot be balanced and the person will slip. So I hope you have understood. We will come with a next topic, very interesting topic, that will help you in understanding an important concept, and many problems can be solved.